Good morning, students. Today we are going to discuss about the second part of the resistors. In the last class, we discussed about the resistor units, definition, and the color coding of the resistor, how to calculate the values of the resistor by using the color code. Today class we are trying to discuss about the different types of the resistors. Different types of resistors. We already discussed that the resistors are classified into two types: fixed resistors, variable resistors. Fixed resistors are again classified into carbon resistors, precision resistors, wire wound resistors. Again, carbon resistors are divided into carbon composition type resistor, carbon film type resistors. Precision resistors are classified into wire wound resistors, metal film resistors as shown in the slide. Next, coming to the variable resistors. Variable resistors are two types: general purpose resistor, precision type resistor. The general purpose resistors are potentiometers, we can also call it as the pots, and rheostats. Potentiometers again divided into the carbon potentiometer, wire wound potentiometer. The precision type potentiometers are LDRs, thermistors, varistor, trimmers. So like this, the resistors are broadly classified into these classes. Now we are going to discuss about these classification one by one. Now you see the resistors one by one. Already we discussed types of resistors. So once again you try to see the resistors are divided into two ways: fixed resistor and variable resistors. And next, from the fixed resistor we having the carbon composite resistor, film resistor, wire wound resistor, resistance wires are there. Variable resistors we having the rheostat, potentiometer, thermistor, humistor, varistor, photoresistor. Like that we having the variable resistors. Now we try to discuss briefly about the resistors. Carbon composite resistor. You see the diagram. The carbon composite resistor having the low inductance, ideal for high frequency applications. This resistance very cheap to make, having the very large tolerance. This is the carbon composite resistor. Coming to the film resistor, the resistivity value of the resistor is controlled by increasing the desired thickness of the deposited film. So that's why it is called a film resistor. The resistance up to 10 mega ohm can be obtained. It having the tolerance 1% or less. Next one is the wire wound resistors. These resistors made by winding a thin metal alloy wire onto an insulating ceramic former in the form of a spiral helix. It is available in very low ohmic and high precision values, that is 0.01 to 100 kilo ohm. This is called a wire wound resistor. The other one is the rheostat. Rheostat is a adjustable resistor used in applications that require adjustment of current or varying of resistance in an electric circuit. A special type of rheostat is the potentiometer. You can see the rheostat. We again briefly discuss about these topics. Now we try to understand what are these. Next one is the potentiometer. A potentiometer is a part in electronics technology is a three-terminal resistor with a sliding contact that forms an adjustable voltage divider. Potentiometers are commonly used to control electrical devices such as volume controls, joysticks, or etc. Other one is the thermistor. A thermistor is a type of resistor whose resistance varies significantly with the temperature. That's why it is called as a thermistor, thermal resistor. Thermistor can be used as current limiting device for circuit protection as replacements for fuses. Another one is the humistor. A humistor is a type of resistor whose resistance varies significantly with the humidity. That's why it is called a humistor. A humidity sensor measures the humidity level by measuring the change in the resistance of an element. Varistor. A varistor or voltage dependent resistor function is to conduct significantly increased current when voltage is excessive. That is a variable resistor. Voltage dependent resistors. If the voltage varies, the current with that will be increases. Another resistor is the photoresistor. A photoresistor or light dependent resistor, that is called LDR. It exhibits the photoconductivity. Photoresistors in many consumer items such as street lights, clock, radios, alarm devices, etc. we are using the photoresistors. So these are the simple classification of the resistors in a lighter way. Now we try to compare these resistors one with the another. So now in detail we discuss about the carbon resistors. The carbon resistors are made of carbon. The carbon resistors are of two types: carbon composition resistor, carbon film resistors. We already discussed. Carbon composition resistor, you can see the appearance of the resistors in this slide. Carbon composition resistors are made of fine powder of carbon or graphite mixed with a resin binder in proper proportion. That's why it is called as a carbon composition resistor. The fine powder of carbon or graphite mixed with a resin binder in a proper proportion. It is available in the range of 1 ohm to 20 mega ohm. The power ratings of the carbon composition resistors are 1 by 10, 1 by 8, 1 by 4, 1 by 2, 1 and 2 watts. So these are the power ratings of the carbon composition resistor. So what are the advantages of this carbon composition is these are small in size, available in wide resistance range, and the cost is cheap, heavy, having the good radio frequency performance. That's why these are the advantages. But what are the disadvantages of these are carbon composition resistors have high tolerance but the low precision. the precision is important, but these are gets heated up easily. Very easily the resistors are heated. Resistance values varies with the age because we are using the powder. After getting the aging, the value is varies, and it is not useful for power levels above 5 watts. Above 5 watts, carbon composition resistors are not useful. So that's why we having the another one, carbon film resistors. The carbon film resistors, these are made by depositing a very thin film. Depositing a very thin film of carbon on a ceramic or glass substrate. We use the thin film instead of carbon composition. So these are carbon films are two types. One is the thin film resistor, second one is the thick film resistors. Thin film resistors are the capacity is less than 5 micrometers. Thick film resistor having the film thinness is greater than the 5 micrometers. So these are the two classification in the carbon film resistor. The main thing is we are use the carbon in the form of the film. The advantages of carbon film resistors, these are available from very small, that is less than 1 ohm, to very large, that is many mega ohms. The size is very small. These are offers good high frequency performance, and it is cheap. The disadvantage of these film resistors are these are cannot withstand high temperatures. At the high temperature, the film resistors are not suitable and cannot withstand for mechanical shocks. Whenever mechanical shocks occurs, these films may go to damaged and we don't get the proper output. Sensitivity to the moisture, and these are also chemically reactive, hence these are unstable. So these are the disadvantages of the carbon film resistor. Another type is wire-wound resistors. The wire-wound resistor, these are constructed from a long fine wire of nickel chromium wound on a ceramic core. That's why it is called a wire-wound resistor. The wire is wounded on a ceramic core. Here we are using the wire is nickel chromium wire. The wire wound resistors are of two types: power wire wound resistors, precision wire wound resistors. The advantages of these wire wound resistors are these are can be produced with highly accurate resistance values with very low resistance, very low tolerance. That is a very good advantage. High accuracy values and with the low tolerance value. With these can withstand large power dissipation and can be used in high temperature also. And these are capable of carrying very large currents. That's why the wire wound resistors are somewhat more useful in this particular environment, it having the very stable resistance value. The disadvantage of these are, the main disadvantage is very large in size and weight, because of in the form of wire the size is very large and weight also large, and for this it having the very costly. The wires can break, leading to the breakdown of the circuit in which these are used. The power type wire wound resistors are not suitable beyond the 200 kHz. That is, these resistors are frequency sensitive resistors. These are the some of disadvantage of the wire wound resistors. Now we try to compare the various type of resistors. We are discussed about the carbon composition resistors, carbon film resistors, and wire wound resistors. We try to compare these three resistors. Now we try to see the comparison between these three resistors. First one is the size. You know that the size of the carbon composition is small, carbon film also small, but the wire wound is very large. Power ratings are coming to the carbon type very low. Low, carbon film also low, but wire wound having the high power rating, that is a 1 watt to 1000 watt. The accuracy of carbon composition is low, carbon film also low, but wire wound is high. The temperature coefficient of the resistance is carbon composition and carbon film is negative, but coming to the wire wound resistance, the value is 0. Value is 0. So we having the various type, the comparison you can see resistance range. Carbon composition are available 1 ohm to 22 mega ohms. Carbon film available 10 to 10 mega ohm. Wire wound available 0.1 ohm to 1 mega ohm. The tolerance of the carbon composition is 5% to the 10%. Coming to the carbon film, it having the 1% to the 5%. The wire wound resistor having the 5% to 0.5% to 1%. The operating temperature is carbon composition having the minus 55 degrees to 150 degrees. Carbon film having the minus 40 degrees to 120 degrees. But coming to the wire wound having the 55 degrees to 365 degrees centigrade. The working voltage, the carbon composition may useful at 150 to 750 voltage. Carbon film having up to 500 volts only. The wire wound is less than 300 volts. It will be useful. So we having the application where we use generally the carbon composition is used in power amplifiers and all general purpose applications. Coming to the carbon film resistors are used in high stability circuits like computers, telephones, high fidelity amplifiers. Coming to the wire wound resistors are used in power supplies, control circuits, TV receivers, bridges and various instruments are used. So these are the comparison between the carbon and wire wound potentiometer. Now we try to go with the now we try to discuss about the comparison between the carbon and wire wound potentiometers. In the carbon potentiometers, the resistive materials used in carbon composition, that is mixture of carbon and resin binder. In the wire wound potentiometer, the resistive element used is nichrome wire, that is alloy of nickel and chromium. So comparison between the resistance value of carbon potentiometer is very high. It varies from 100 ohm to 25 mega ohm. The resistance value of wire wound is very low, that is 0.1 ohm to 150 kilo ohm. The power rating of the carbon potentiometer is low, that is 1 by 4th of the watts to 2 watts. The power rating of the wire wound is high. So this is the comparison between the carbon and wire wound potentiometer. It is easy to obtain a taper in a carbon potentiometer. It is very difficult to obtain a taper in case of wire wound potentiometer. You know, the taper means a movable contact on the surface of the carbon composition or wire wound. The stability of carbon potentiometer is very low. The stability of wire wound potentiometer is more due to its rugged construction. Comparison between the carbon and wire wound potentiometer we are discussing. The carbon potentiometer is widely used in the volume control of radio and TV receivers. The wire wound potentiometer is widely used in the voltage control in various electronic equipment. The parameters we try to compare, that is a carbon potentiometer, the part indicate the carbon potentiometer, wire wound part, wire wound potentiometer. Now we try to compare with the parameter. The resistive element which we are using is carbon composition mixture in carbon part, nichrome wire in wire wound part. The resistance value is carbon part having a high, the wire wound part having low. The power rating is carbon part having the low and wire wound part having the high power rating. The usage is low current circuits we use the carbon part, high current circuit we use the wire wound part. The taper carbon part having the easy and wire wound part having the difficulty. Already we discussed, stability is less in the carbon part, more in the wire wound part. The applications, volume controllers, carbon part, voltage controllers in the wire wound part. The operation is silent for the carbon part, the wire wound having the noisy, some type of noise will occur in the wire wound part. The temperature coefficient is very high in the carbon part. Coming to the wire wound part, it is low. You can see the carbon potentiometer how they are. You can see external view and internal view. Carbon potentiometer, we having the carbon composition resistance element. We have 3 terminals are there. The shaft is there. Spring wiper contact is there. The rotating arm, whenever we rotate the shaft, it will move from the first contact to the third contact. This is the carbon potentiometer or carbon composition potentiometer. So coming to the wire wound, you can see wire wound means the wire is wounded on the particular ceramic core. So here also we having the resistant winding is there, rotating contact is there, terminals are there, shaft is there. Depending on the shaft movement, potentiometer will give the resistance values. So we already discussed about the tapering in the potentiometer. What is the tapering or tapering? Tapering, we can also call it as a tapering. Already I explained, in the potentiometer we having the one type of movable contact is there. That contact is called as the tap or tapering. We can say is in the potentiometer, the manner in which the resistance R varies with the rotation of the shaft is known as the tapering or tapering. The rotation of the shaft is called as a tapering. The tapering in the potentiometer is effected in order to obtain different value of resistance. This can be done in two ways: linear tapering and non-linear tapering. Two methods are there: linear tapering and non-linear tapering. Linear tapering, you can see the diagram. So what we are linearly, the whatever the shaft is there, that will move from the starting to ending. That is called as the linear tapering, linear type tapering. So now you see here linear type. What is the meaning? In linear tapered potentiometers, the width of the resistive element is uniform throughout its length. The main concept is the width of the resistance element is constant. So that's why it is called as a linear tapering. In linear tapered potentiometer, the resistance value changes in direct proportion to the shaft rotation. That is, the resistance value is proportional to the rotation of the shaft. Why? Because the total portion of the shaft is equal distance. The another one is the rheostat. A rheostat is a multi-terminal variable. It having the two terminal. Rheostats are designed to handle much higher voltage and current. The circuit symbol you can see, we having the 1 and 2 symbols, 3 terminals are there, but we use the 1 and 2 terminal device. Cylindrical and circular rheostat, you can see how it is. It having the movable contact, ceramic tube is there. On the ceramic tube we having the conducting lines are there. The movable contact moves from the one position starting to ending. So what we are getting, the contacts are starting and the movable point. These 2 points gives the resistance value. A high powered toroidal wire wound rheostat, you can see the structure how it is. How we can construct a rheostat. We try to discuss about the construction of a rheostat. Rheostats are constructed as a resistive wire wrapped to form a toroid coil with the wiper moving over the upper surface of the toroid, sliding from one turn of the wire to the next. That movement gives the resistance value. Sometimes a rheostat is made from resistance wire wound on a heat resisting cylinder with the slider made from a number of metal fingers that grip lightly onto a small portion of the tons of resistance wire. The fingers can be moved along the coil of resistance wire by sliding knob, thus changing the tapping point. They are usually used as variable resistors rather than variable potential dividers. That is variable resistors. You can see the rheostat how they are. These are the different types of rheostats and the size of the rheostats. So this is the one another type. You can see the diagram. So this is another type. So many varieties are there. So this is another type. Another. So rheostat construction. A rheostat is constructed by winding a resistance wire around a farmer. Winding a resistance wire around a farmer. The farmer can be round and flat or cylindrical. It may be round or it may be flat or it may be cylindrical. A wiper blade is then arranged to touch the surface of the resistance wire and is made to be movable. The power is supplied to both ends of the resistance wire and a wire is attached to the slider. The voltage at the slider wire is determined by the position of the slider on the resistance wire. By removing the sliding connection along the winding, the resistive wire is made effectively longer or shorter, thus increasing or reducing the resistance in the circuit to which it is attached. If both ends of the windings are used and the central slider is still connected, then as one slide gets shorter, the other gets longer and a voltage or potential divider is formed. If you use both the sides, it may be used as a potential divider. A rheostat consists of nichrome wire resistors connected in the series or parallel and connected to wound rotor of motors by slide wire contacts. The resistors are encased in a metal housing where it is immersed in transformed oil coolant. During startup of motors, the rheostat is set at maximum resistance value. After gradually the setting is increased, reducing the resistance connected to the rotor such that the motor speed also increases. Finally, the resistance is zero when the wiper contacts are short circuited at the last stage and the motor rotates at rated RPM. The rheostats are used in wound rotor motors to reduce its starting torque and current. That is the main advantage of the rheostats. To operate the motors, we use the rheostat. At the beginning, we use the rheostat at the high resistance. After starting, by using the wiper, slowly reduce the resistance. At last, after getting zero resistance, the motor will rotate on the rated speed, rated RPM. Rheostats can still be used as dimmers of lighting circuit. Lighting circuit dimmers means it may dim the light of the circuits. Specifications of the rheostats. The rheostat's general resistance value is 1 ohm to 10 kilo ohm. The power ratings are 100 watts. The temperature is withstand up to 300 degree centigrades. So these are the some of the specifications of the rheostat. Now we try to discuss about the applications of the rheostat. Applications of the rheostat. The rheostats are used in the heater and oven controls. The meaning is it controls the resistance, so it will control the heater and oven operations, and these are used in light dimming control. The rheostats are used in speed control of the DC motor and also used in arc welding process. arc welding process. So these are the some of the applications of the rheostat. The rheostat is a beautiful element which is used to control the or vary the resistance of the circuit. This variable resistance make very comfort in controlling the heat in the heater and ovens, light in the light dimming circuits, and the control of the DC motors and welding process. So these are the main applications of the rheostat. Next, we try to discuss about the effect of temperature on resistance. How the temperature affects the resistance value. In this, we try to discuss about the effect of temperature. The effect of temperature on resistance is different in different materials. The resistance of pure metals like aluminum, copper increases with increases in temperature. It means that all metals exhibit positive temperature coefficient of resistance. The metals, generally the metal exhibit the positive temperature coefficient. In alloys, the increase in resistance with temperature is very small. Temperature increases, the resistance increase very small with respect to the temperature. The resistance of semiconductor and insulators are decreases with respect to the increasing in the temperature. The thing is, for the conductor, temperature increases, they behave one way. If the temperature increases, semiconductor devices behaves in another way. These semiconductors exhibit the negative temperature coefficient, that is, temperature increases, the conductivity of the semiconductor increases, that way resistance is decreases. That's why it is called a negative temperature coefficient. So now we are going to discuss about the temperature coefficient of a resistance. Temperature coefficient of resistance. For metallic conductors, the resistance increases with increasing with the temperature. This increase in resistance depends directly on its initial resistance, the rise in the temperature, the nature of the material. Like this, these three factors affect the temperature of the conducting material. What initially the resistance, having its resistance, what amount of temperature increases from the starting value, what type of material are used in manufacturing the resistor. For that, we try to derive the temperature coefficient of a resistance. One formula. This formula indicates the change in the temperature and change in the resistance of a particular resistor value. Let us consider a conductor whose resistance is R at 0 degree centigrade and at T degree centigrade. The increase in resistance is given by, or change in the resistance is given by, delta R equals to the RT minus R0. RT is the change in the resistance with respect to the temperature. R0 is the initial resistance. RT minus R0 is proportional to the R0 into T. That is, the increase in resistance depends on its initial resistance and rise in temperature. We can write like this. The increase, that is the delta R, is proportional to the starting resistance and its increased temperature, that is RT minus R naught equals to alpha R naught T, or you can also write RT equals to R naught into 1 plus alpha T. This gives the change in the resistance when the temperature changes. The R naught gives the initial resistance, alpha gives the material property, the temperature coefficient of the material, T gives the change in the temperature. The total expressions give the resistance value when the temperature changes from the 0 to T value. So this equations gives us this equation gives us the resistance value. From this we can calculate so many values. We can calculate initial value of the resistance or change in the resistance, and also we can calculate the material property, that is the temperature coefficient of the material also we can calculate. Now we try to discuss about the common faults in resistors. What are the common faults occurred in the resistors? Let's see. The resistors are reliable components and their rate of failure is very low. The still faults do occur in the resistors. Some common faults which will occur in resistors are open resistor. First fault is the open resistor. A resistor may become open by excessive current through the resistor. If you pass the excessive current through the resistor, it may be open. That is called as a open resistor. The next one is mechanical stress in carbon resistor and corrosion in metal resistor may also result in open resistor. Coming to the carbon resistor, mechanical stress, if it provides more mechanical stress and corrosion, it may makes the resistors will be open. Increase in the value of resistance. The other fault is the value of the resistance is increases. The meaning is the value of carbon resistors may increase due to lack of proper environmental conditions. If the proper conditions are not maintained, the humidity or moisture may form on the resistor. It may increase or decrease the value of the resistor. For example, increase in temperature increases the resistance value of the carbon resistor. The third one is short circuited resistor. Short circuited resistors. Generally, a resistor does not become short circuited, but a meter may show short due to some component that is connected across the resistor may get shorted. The meaning is generally the resistor never becomes short circuited. If any components, resistors or capacitors or transistors are connected across that particular resistor, the meter may show it is short circuited. So this is the another fault of the resistors. A big problem is noise in the resistors. Some resistors, random motion of electrons in a resistor results in noise called Johnson noise or white noise. Some noise is normal depending on the value of resistance and temperature. However, bad contacts of end connectors may also cause noise higher than the normal. So this is because of the bad contacts of the end connectors and sometimes it may having internally Johnson noise or white noise are occurred in the resistors. If you don't connect properly, we get the higher noise than the normal one. The fifth one is intermittent contact. Intermittent contact of the resistor. The particles of dust, grease, or abrasive matter between the wiper and resistance material may result in intermittent contact and may increase noise signal and may cause intermittent fault. These are mainly occurred in the potentiometers rheostats because of the particles of dust, grease or abrasive matter between the wiper and the resistance track. So we also take care about the intermittent contact. And next one is dry or cold solder joint. The meaning is the dry or cold solder joint may behave as high resistance leads. A resistor cannot be repaired, and hence if the fault is in the resistor itself, it should be replaced with a good one of the same specifications. The meaning is if the solder joint is may having the high resistance with respect to the resistor, so we need to replace that resistor with the another same specification resistor. So like this we having the total 6 faults occurs in the resistor. We need to avoid these faults and make the connection sure we can get the perfect connecting of the resistors. The dry or cold solder joint we need to take care by human. Another one is the intermittent contact and noise in the resistors and short circuited resistors. Next one is the increase in the value of the resistance. Another one is open resistors. We need to reduce these 6 type of noises. We need to take care of these 6 noises so that we can make the resistive circuit noise free circuit. Thank you. This is all about the resistor.